Okay, hey everybody. Welcome to the first Lido node operator community call of 2024. This is volume 14, and we have an action-packed agenda, so we're gonna get started right away and try to keep to the timetable. So just going really quickly through our agenda. First of all, we're going to have a guest from Eden Network telling us about their mempool streamer and public datasets. Then we're gonna have a simple DVT update from Lido DAO contributor Will, followed up by a small intermission where those of you watching the stream will be able to claim an oat, basically something like a POAP. Then Dimitri from the community staking module team will be telling us about the CSM integration request for proposals. And last but of course not least, Jim from Attestant is going to be telling us about the new Vouch features in a very, very timely way, because the topic du jour these days is Ethereum execution layer client diversification. And so Vouch is a really, really important tool to help us minimize the possible risks of execution layer and client layer bugs. All right, so first up, we're going to have Andreas from Eden Network tell us about the mempool streamer and public datasets. Andreas, whenever you're ready, feel free to share your screen and get started.
Awesome. Thank you so much. So appreciate being invited for the call and looking forward to tell a little bit more about Eden and the mempool streaming service. So just to start off, to set the stage, I'm not a part of the engineering team on the Eden side. So like I do partnership and management of internal processes and structure and product presentations. So I have like, I would say maybe not the most exciting background, but like an education in auditing and financing, and been running a few companies in the past until I was introduced to the team behind Eden Network back in 2021. So to jump right into it, in terms of, oh, I need to click here. In terms of the story of Eden, so officially the core team members started out a long time ago, but basically come together in 2021 to the idea of block priorities and MEV products, and basically announced the story and the products for Eden, and managed to raise a capital round supported by a few of the bigger VCs in the ecosystem. And after that, we managed to expand the team into around 15 professionals, where around 10 of those are engineers, and majority of those guys have native blockchain experience, all with a focus primarily on MEV and infrastructure surrounding the operations of nodes. We have teams across the time zones of US and the European Union, and that basically should put us in a position to keep the infrastructure operational, and has been doing that through the years. Also, we've been lucky enough to have a lot of good partner conversations over the years, especially after we released the updated Eden Relay, and managed to reach out to a lot of you guys as well and have you on board through the story of what we've been doing. That's a little bit of background of why Eden came and where we are today. And then let's jump into the actual partnership we have with you guys. So the Eden Relay was produced after the merge, and we were very, very lucky that you guys decided to onboard it from the start. And I just checked a few of the numbers, and I can see like we did manage to produce around 500 blocks and around 65 ETH of MEV rewards for Lido operators since September last year. On top of that, we had like internal conversations when it comes to OFAC and filtering. As we have US team members, we decided that the best way forward was to try to be somehow compliant without knowing what compliance really is. And we basically came up with the toolset of ZeroX Protect, which is also an open source toolset, which is available to anyone who's interested. And we have been using that on the Eden Relay and the Eden builders ever since the merge, and we launched the product set. Also, we did release a public data set for MEV boots and bits payloads, which was put on the forum, I think, a few months ago as well. And we hope to continue basically adding to that database and sharing information with the community of Lido and vice versa. Happy to receive any information as well from anyone interested in sharing. So, what we all came to hear about: the introduction of the mempool streamer and the fact sheet. So basically, the challenge we had, everyone has, is the transactions are floating around everywhere on the network across the world, and all the validators nodes are basically dispersed in a way, so it's difficult to capture all of the transactions and get insights and basically produce the products fast enough. So we decided to basically roll out speed RPC, which I will go into a little bit more depth in another slide. But based on the speed RPC, we managed to build out a propagated node set that is basically reading all the local mempools in a way, and then dispersing that into a set of 3 endpoints, which is available for everyone through the mempool stream service online. So, in terms of why we believe our mempool stream service is useful, is that first of all, it's still in alpha, so it just came out of closed alpha and now available to anyone who's interested. So it's free to use, and it's, from our perspective, what we hear, can easily compete with the best in the market. Plus, it helps everyone build better blocks. It's a plug-and-play solution, which has only 3 endpoints, and it's able, at the moment, capable of streaming up to 1 million daily stream transactions, which 95% of them are included on-chain. Diving a little bit more deeper into why it works or how it works, is, as I said, we set up like 3 endpoints for everyone to be as close to the endpoint as possible. But underneath the endpoints, we basically added infrastructure propagation nodes that's able to read the dispersed mempools across the network and basically transmit that information as fast as possible to the end user through this mempool streaming service. And at the moment, it's possible to connect through WebSockets and gRPC for anyone who's interested. And as I said, we just publicly launched the access here in early January after a period of a closed alpha in Q4 last year, where it was just a subset of users who got the access for providing feedback to the service. And we received very good feedback in terms of performance and been able to iterate on the version numbers and feel pretty comfortable the current version available to anyone right now online. In terms of use cases, so we see that in general, we offer fast, real, comprehensive access to mempools across the world, and it basically helps, as we said, most people get access and build more valuable blocks, and it illuminates, as I'm using a fancy word, the transaction flow for research, and allows you to basically capture that data and share it in data sets, as we will be digging into later as well in the presentation. So by the end of the day, hopefully this should actually apply to higher rewards for node operators in case it's being used in the right way. When it comes to what else Eden is currently offering, as I said, like our team has been focusing on the MEV part of the network since we started, and before that even. And we now have like a subset of tools and services which is available to everyone. At the moment, we are focusing a lot on the mempool streamer, as it's like a first product on top of our recently released Eden Speed RPC, where we actually build out the infrastructure to be able to support the streamer. On top of that, we also have the relay, which we've been operating since the merge. We have our own builders, which is basically available to any searchers who's willing to share the traffic with us. And we, of course, have the original transaction protection RPC, which everyone also is basically able to use if they're interested. And most recently, we added a more like focused group inside the team to get build out more MEV datasets. And we'll dig into that in a separate slide later. And now what everyone came to see, I hope. Now we'll see if I can make this link work. But in essence, as It's a public alpha. It is available to everyone, and it should be able to display. So I will try to click and see if it's actually possible. Let's see, I'm not probably need to share another screen, I guess. Mempool demo, share. So I hope everyone is able to see the new screen layout. And as you see on the website, it's live right now. So I hope nothing breaks when I click the button. But the three endpoints are operational: EU West and US East, Tokyo. And once I click this, we should start seeing the transactions actually coming through from these endpoints and the propagation network below it. And as I said, this should be able to compete with most of the paid services in the market today. And it's completely free for everyone to go and take a look at. There are filters enabled, and we also have the ability to basically show the actual raw data of the transaction flow streamed directly to you. So we are very proud and very happy with the state of the service right now, and we are looking forward to basically continue to receiving feedback from the users once they continue accessing and testing the service. Then I will switch back to the presentation. Ooh. So I hope that got some attention, and everyone will now be clicking our mempool import. We will be tracking it. Anyhow, we also have our public data sets where I said we already shared one of those with the Lido community a few months ago. And at the moment, there is around 6 data sets available, freely available for anyone to be able to access, where we basically have the historic data of different aspects of what's going on when it comes to the network or the ecosystem of MEV. And our goal is to continue adding more and more to this data set and continue to make it publicly available. The next piece, I believe, is about timing. So keep your eyes on that. We will also be sharing it as soon as it's ready. And that is the end of the presentation. I appreciate again for the invitation, and I hope we will be able to share more with you guys in the future. Thank you so much.
Thank you, Andreas. That was really, really cool. I'm going to pause just for a second to see if there's any questions on YouTube or in Zoom. I do have one question. So the transactions that you're streaming, those are transactions in the mempool, right? And you're showing all transactions at this point, right? So in the relay, at least, you might be working with builders, or you might be enforcing some sort of transaction filtering, right, based on like sanctions list. But in terms of the raw data that's appearing in the streaming, it includes all transactions, right?
That includes all transactions, yes. There are pending transactions from the mempool across the propagation network. We don't filter anything.
Okay, that's really, really interesting. I remember there was a RFP that was done by the Lido grants organization. I guess it's probably like 9 months ago, where a bunch of different teams created censorship monitoring tools for the network. It would be cool, like in a live streaming explorer, basically, if we could even see like what transactions are taking like a while to get picked up, you know, like how long they're staying in the mempool. And then maybe if you do like labeling of these transactions, you can try to have a semi-live way or semi-real-time way of like seeing this happening. You know, so transactions might be staying in the mempool because they have low gas. They might be staying in the mempool because they're like actively being censored for whatever reason, or there might be a bunch of different reasons. So it would be pretty interesting if you guys could incorporate like some sort of dynamic labeling into the system.
Okay, very good feedback. I will be happy to take it back to the team and let you know what they say.
Thank you. I don't see any questions, but I do see a lot of comments from YouTube saying that it looks really, really cool and that it's invaluable. So thank you for sharing it with us.
Thank you so much, guys, for having us. Thank you.
Our pleasure. All right, Will, you're next up.
Everyone, I'm Will, contributor to Lido. We'll be talking about the updates we just posted to the forums last week about the simple DBT module and the test nets that are ongoing. So kicking things off on the OBL side, you can see here there's 3 different tables. These are the testnet metrics that were analyzed per rated network. Really great news. So OBL successfully passed all of the metrics that were being examined here. You can see on the left, that chart minimum testnet success characteristics. So per the simple DBT module proposal, these are the metrics that needed to be achieved for OBL to move forward onto mainnet without having a revote or needing to do another testnet. So this included uptime of 95%, a block proposal success rate of 70% minimum, and then being above the average network attestation effectiveness. And so for the 45-day period, network attestation effectiveness was 78.8%. You can see on the rightmost chart, the aggregate testnet metrics for all 32 clusters that participated. Uptime was almost 98%. The block proposal success rate was 71%, a bit above that. Attestation effectiveness was 84.5%, and validator effectiveness, which also includes some measurement of block proposals, was also 84.5%, slightly different at a lower decimal, but right in that same range. You can see that all of these metrics also beat the Haleski aggregate metrics for all validators on the network. You can see that in the middle chart, where we also have the validator effectiveness. So this is obviously very exciting. The OBL technology has beat the metrics that were required to move forward onto mainnet. The testnet is currently in the process of wrapping up. All the validators at this point have been exited. We're doing the reward claiming process. I'll talk more about how this is working in a few moments. But basically, all of the participants receive their share of rewards via splitters, and they are testing the claiming process for this. So in terms of next steps for OBL, we are currently working on a pretty extensive blog post that's going to really cover everything from the setup of clusters to the DKG process, to then the operations process. This will also include a lot of information about the cluster, the technology, the cluster and the technology, the DBT provider's performance in general. Following this, so the Lido node operator subgovernance group, which is the subcommittee of the DAO that's responsible for helping with onboarding rounds, will be meeting to discuss the potential clusters and participants that will move forward onto mainnet. When the LNOSG has this meeting, a summary of it and the proposed list of clusters will be published to the forums. We'll be looking to receive feedback from any DAO or community members on that list. And if there's no issue, then the participants will be okay to move forward onto mainnet. So as a reminder, the proposal initially calls for a total of 24 clusters, 12 from OBL, 12 from SSV, within the first 30 days of going live. So that would be at least 72 net new node operators, assuming one curated node operator per cluster, which would be pretty encouraging. And then combined with SSV, would add about 100 net new node operators to the protocol just from the kickoff of the first 24 clusters. Over time, additional clusters will be added. There is a 30-day monitoring period with 5 validators each for the initial 30 days, and then those metrics will be slowly ramped up over the coming months. On the SSV side, so we are currently in the process of getting everything rolling. So the 32 clusters have been formed, and DKGs were initially completed. There was a issue that occurred with 2 of the clusters where, and really this was a user error, and we've improved some of the checks around this, given how transactions are being built in safe, where validators were registered initially to the wrong cluster. So these validators have all now been exited. DKGs, I believe, as of about 10 minutes ago, are all complete as well. And so the 30 to 45-day monitoring period will be kicking off in about probably 24 hours when validators are deposited to again. So in terms of this monitoring period, it takes into account either 2 periods. So the 30 to 45-day period from the activation of validators, or the 30 to 45-day period prior to exiting of validators. We have not done extensive analysis in the performance so far, as clusters are still all getting sorted. But in the next week, we should be able to raise key limits, assuming that attestation effectiveness, uptime, and block proposals are looking good. Given the number of validators on Haleski, we don't get a great read on block proposal success rate from the initial 5 per cluster. But when we raise key limits to 50 validators each, we should start to see a lot more data from that side. So in general for SSV, this should last for about 4 to 6 weeks in terms of testing. And we'll have more updates to give both in the forums and probably on this call next month in terms of what is going on in this testnet. But the goal here is for the simple DBT module to be deployed within Q1 and for both OBOL and SSV node operators, assuming SSV also is able to achieve these metrics, to be live on mainnet, running validators via the Lido protocol within Q1 as well. Similar to OBOL, there will also be a blog post here covering the details from cluster formation to the monitoring period. There's a few other updates, and so this is all covered more extensively, especially on some of the performance aspects of the OBOL trial in the forum post. You can go ahead and scan this QR code. Would highly encourage reading it because there's a lot of detail here, and you can learn more about how the OBOL testnet specifically went. But there's a couple of other topics that were discussed outside of just the testnet specifically. So there's more detail added to the simple DBT module committee. This was initially discussed in the proposal. And as a reminder, this is the group of contributors that will be members of a multi-sig that are responsible for creating and executing easy track motions for the simple DBT module. This improves the operational execution and efficiency for the module, rather than having on-chain votes for adding node operators when there will be many and there will be multiple waves of them. The DAO voted to give that responsibility to the module committee, and the module committee will be making very transparent posts on the forum thread as an ongoing basis before taking any actions. All of these easy track motions are also vetoable with LDO. So the module committee has the ability to create and deactivate clusters through the simple DBT module to raise and lower key limits for those clusters, and then manage their individual manager address and the reward address. The manager address is the address they use in their cluster multi-sigs that represent their entries in the Lido node operator registry for simple DBT. This committee will be made up of 3 members of the Lido node operator subgovernance group, 2 Lido DAO contributors, 1 OBOL contributor, and 1 SSV DAO contributor, and that will be the makeup. So the next point that's also talked about within the forum post is basically reward distribution. This is done with a set of smart contracts. First, there's a wrapper that was developed by the OBOL team. This wraps ST-ETH into wrap staked ETH and optionally takes a reward share. So the ST-ETH needs to be wrapped because the next set of contracts based on OX splits or OX splits itself does not support rebasing tokens. And OBOL also has a reward share. As a reminder, on the SSV side, they take their reward share via the SSV token and network fee. Once the wrapper is deployed, this is set as the reward address for all the clusters. And then there is an OX split of smart contracts that actually allows for the distribution of rewards to node operators. So this is the splitter that actually gives each node operator their respective share of the rewards for running the validator. And on the OBOL side, we're in the process of testing this now. Finally, we have another round of testnets coming, likely starting in the early spring. Would highly encourage anyone that hasn't signed up to do so. All solo stakers, all community stakers, and professional node operators are welcome to apply. The requirements here really are just having prior experience with OBOL or SSV. So there's plenty of time before the next testnet will start, at least a month. You can go onto the SSV website or the OBOL website, read their documentation, and you can get a testnet validator set up and just apply via this link, and you likely will be included. We're really looking for highly performant operators from this next testnet to also join the simple DBT module. So it's a really great opportunity for people that want to run validators on mainnet and are interested in DBT. Highly encourage you to take part. If you haven't set up a validator before, you can go back to that prior QR code where the forum post lies, and there is a bunch of links to some workshops that were hosted by Lido community lifeguards explaining and teaching how to set up both OBOL and SSV validators. So that's what we have, and thanks very much.
Thank you, Will, for providing that update. I think actually before Dimitri, we have a small intermission in theory. I'm just waiting for the next slide to come up. I think there's some technical difficulties on the streamer side. So in the meantime, Any questions for Will or anything about Simple DVT? I see we have a lot of participants in the chat that were running some of the DVT clusters. I guess they probably don't have a lot of questions because they already participated. One sec, I'll be right back. Okay, I think we're back. So there should be a slide coming up shortly on your screens with the intermission. The intermission is basically just for people to take a quick rest and mint our oats, basically the Galaxy equivalent of POAPs. There's a QR code which you can scan on your phones, or if you're watching us from your desktop, there's a link in the description to the video. And the password for this oat is staked. STAKED, all lowercase. So feel free to mint it some point between now and tomorrow because the oat is set to expire. We'll be issuing these for all of the community calls throughout the month. Actually, there's probably nothing in store for you if you're collecting them. They're mostly just for people that like collecting badges. Irina in the chat has a question around how the names for the DVT clusters were generated. So I think for OBOL, actually, they were generated using GPT. And for SSV, they were generated using a script that one of the developers, Sergey, on the CSM team wrote for us. We had the idea of actually generating the names based on the cluster multisig address deterministically. And we're going to try to see if something like that can be used. But then we realized that cluster sigs may need to be redone for various reasons. And so maybe it's not the best way to do it. But we hope to keep something kind of like playful for this, even for the mainnet release. Okay, so we'll move on from the intermission just whenever Dimitri is ready. And he's going to present to us the CSM integration request for proposal.
Yeah, hello. Happy to be here. I'm Dimitri, a technical leader of a group of contributors working on community staking initiative. And today I want to give you a short overview of a not that recently, but posted request for proposals for CSM and Simple DVT integrations. As you all know, Simple DVT is about to get to mainnet. We just heard the updates on it. And CSM, the first ever permissionless module in Lido, is also about to get to the mainnet within this year. And what do we need for validation, actually? On top of a great protocol with great superb conditions, you also need to run the validator itself, node, validator, and all that stuff around it. And this is a crucial part of validation itself. That's why we, as a group of contributors, think and believe that we don't need to create yet another tool that will be tailored specifically for Lido stuff to run a node, to run a validator, because there are already a lot of them on the market. And we do believe that we need this integrations, we need to have this experience of setting up a validator, nodes, and everything else as easy as possible so that community stakers will not only be able to join Lido, but will be able to do it in the smoothest and easiest way possible. So what do we see as integration? When we speak about integration, we assume that existing software providers or software plus hardware providers who are already working on building software to prepare this validation setup, to maintain validation setup, will integrate CSM and simple DVT in terms of parameters and something else, we will talk about it later, into their systems so that community staker will be able to use software that he prefers much or the most while participating in CSM, simple DVT, and probably any other protocol that also is supported by this software. Now let's take a closer look on how the actual integration might look like. To keep it simple, we prepared a short guideline. We created 4 tiers of integration, starting with the tier 0, the very basic integration, the very essential things like setting up node, setting up validator, NEV boost client, and on top of that, preparing the correct parameters for deposit data, so the message that should be submitted to the deposit contract, NEV boost configuration, and other basic stuff. And no more than that. So really simple, and it will help community stakers not to mess up with the configuration and numbers and so on. The second tier that is built on top of the previous one, as well as the others, aims to add additional functionality so that using a tool, node operator will not only be able to set up and maintain validator and nodes, but will also be able to view some parameters from the simple DVT or CSM as a smart contract, and also get alerts about the most important events that he needs to react to. Tier 2 is also built on top of the previous tiers and adds on-chain interactions. We all know that for some of the tools that help prepare a validator setup, this thing with connecting a wallet is not an easy task, and not all of the tools actually support it. That's why this is only included in a tier 2, where you can not only prepare, set up, see parameters, but you can also interact with the network without leaving a tool. And the top tier here is tier 3, is everything described before plus graphical UI, where node operator can see all the things happening with his validators, both in terms of local software, in terms of smart contracts, and all other stuff. You can definitely read more about it if you follow the QR code on the screen and read the actual RFP. And the last but not the least here is to answer simple questions. So first of all, who can submit proposals? As I mentioned before, any software providers who are already working on a software to run validator, to run nodes, can easily apply. We are not looking for something that is built on top of nothing. We are looking for partnerships with the software that already exists and users already use it and like it, so that they can not exit or not change software, but keep using their beloved software and also join CSM or simple DVT. What applicants will get? It is really simple Lego grant for actual integration implementation, because we all understand that any implementation has a cost. What should be in the proposal? There are several simple things that should be included. They are also listed in the actual RFP, but let's go through them very quickly. So the general overview of the tool that is integration is aimed to build on top of. The design of the integration, how the developers see what they are willing to implement, probably referring to an integration tier that will be great, or any other ideas. So you should never limit yourself with the described tiers. You can propose to improve integration, to add some astonishing features that we never thought of. That will be great. For sure, it should include request for budget, timelines of a development, so how long it will take. Keep in mind that simple DVT will go live on mainnet pretty soon. There will be several waves for sure, but we'll also need to keep it in mind, and we definitely need to keep in mind CSM timeline, and CSM will most likely go to testnet in summer 2024. And the last but not the least, estimation of a maintenance cost, because we all know that it is not enough just to develop something, you also need to support it. So estimation of a maintenance cost will also be valuable here. Where to submit your proposal? It is extremely simple. Go to Lido Research Forum and under Community Initiatives category, create a new topic where you will submit your proposal and further discussions with the LEGO committee will take place. And the final thing, the deadline for the submission is the last day of February, and this year it is luckily February 29th, so you have 1 day extra. That's pretty cool. So make sure to submit your proposal before this date. If you have some questions or you don't know how to properly frame the proposal, or you just need any clarifications, feel free to ask on a forum or in Lido Discord or in any other communication channel where you will be able to reach to Lido contributors. And that's it from my side. Thank you so much. And we are waiting for your proposals, guys. See you.
Thank you very much for that update, Dimitri. I look forward to seeing a lot of the proposals as well. And last but not least, we have Jim from Attestant. Jim, whenever you're ready, feel free to share your screen and you can get started.
Yeah, screen sharing is optimistic. I'm just going to talk, I'm afraid.
All right, that works too.
No slides, so there we go. Okay, yeah, so really wanted just to have a brief overview of what is coming in the next major release of Vouch. So for those of you who are unaware, Vouch is a validator client. It is designed to work with all of the major consensus nodes and designed to offer features that allows certainly for large node operators, but also for smaller node operators to have a little bit more safety, security, and performance in and around their validating. So the first thing that comes with the next release of Vouch is obviously going to be support for Deneb. So we expect this release to come out finally over the next week or two. We're really just waiting for the consensus specs to be finalized, just make sure there are no last minute changes. As soon as they're locked down, we'll release this version. So Deneb support means that will carry us through the next hard fork all the way up until what will eventually be Electra. So that's a good time for us to look at an update and make some minor tweaks. One of the other things that came in relatively recently was the launch of the Haleski testnet. Now, that testnet was a little bit different from most of the other testnets we've done in the past in that it started off with over 1.4 million validators running on it. That caused various stresses and strains in all clients, all implementations and similar. And it allowed us to take a little look at some of the features that we provide at the moment and some of the places where we potentially provide a little bit of optimization. So there are some optimizations going in around reduced connections to beacon nodes. We reduce the number of connections going to each individual beacon node. That reduces memory. We have some significant reductions in both CPU and memory usage again as the number of validators increases. And that's very important because obviously one of the things we need to do is make sure that this validator client remains as efficient as possible. One of the other things that we've been looking at is to understand how our product impacts other people's products. So one of the areas where that came up was looking at validator registration. So one of the parts of talking to MEV relays is that we have to send them a registration for each validator saying what it is, its gas limit, its sphere recipient, and similar. That was all kicking off at the same time. So at a certain point in time within an epoch, every single Vouch installation across the planet would send its data back to the MEV relays. Obviously, that's not great for them. It can cause them to overload slightly. It can certainly slow things down, potentially get in the way of other people trying to create registrations and similar. So one of the things we've done there is we've now started to spread that out. So that information is now spread out. It's picked basically a random time somewhere in the middle 80% of the epoch prior to the one where it matters. We will send all the validator registrations. That means regardless of how many vouchers are running around the planet, we'll be in a situation where the load on the validator, sorry, the MEV relays themselves should be much, much less. Still sticking with MEV relays, one of the features that MEV Boost has is the ability to try to unblind blocks, to go and fetch the unblinded block from all relays that it knows about. So when we fetch a header from an MEV relay. We'll get information about the best block it has. And that will leave us with a list of MEV relays that know about the best block. Now, traditionally, what we did is we went back and we fetched the block that we wanted from only those relays. However, due to the way that the relays work, it's possible that that same block had been passed around in the background whilst we were doing our work of signing and composing the consensus block. And as a result, there are more nodes out there that have that block than we originally knew about. So there's an option in Vouch coming in the next release to say what we can do is we can go and talk to every MEV relay, regardless of if it said it had the block or not. That allows us then to have the best possible chance of returning the block. The reason it is an option rather than just a default is because it does have a downside, and that downside is that it will create noise and errors in a log. If we go to talk to a relay and it doesn't know anything about the block, it will spit out an error. That error will show up in logs, but it'll also show up in our metrics. So rather than enforce that and potentially have people who are monitoring through Prometheus start to get lots of errors, we've made that optional, but it is there and it's available in the docs. The other big piece that is probably the most interesting, given what's happened recently, is that we've also added in a new attestation data strategy. So if you'll give me 2 minutes just to go back and talk about the sort of supermajority issue we're seeing at the moment on the execution side with Geth. I'm going to assume you understand what the problem is. However, what I'd like to say is the problem is not about Geth proposing a bad block. Any consensus, excuse me, any execution node can propose a bad block. We expect that to happen. But what we want is for all of the other execution nodes to then reject that block. What that means is what we actually care about is not if a block has been created correctly, validly or not, because most of the time we can't tell that. What we care about is if the other execution nodes have accepted that block, if they have independently validated that block. So what we can do today in Vouch, and for those of you running Vouch and having Geth in your environment, I strongly recommend you do this. You can set a list of nodes from which you will obtain attestation data. And that list of nodes can be all of your nodes minus those running Geth. What that means, so let's take a simple example. Let's say you have two setups. So you've got 2 execution clients. One is Geth, one is Nethermind. When you come to obtain attestation data, if you fetch it from Geth, Geth could have imported a block that another Geth made. Bear in mind, it doesn't have to be our local block, our local instance that proposed the block. It could be any instance that proposed the block. But if Geth has imported that block and considers it valid, even though it is not valid according to the spec, then it will give us an attestation that includes that block on chain. If we go to Nethermind and we ask it for an attestation, if it has attempted to import that block from Geth, seen it is invalid according to the specs and rejected it, the attestation will be for a chain that does not include that block. So ultimately what we're trying to do is not remove Geth from our environment. It's very, very important. Geth gives us lots of good things. It's a highly performant system. It runs well. It generates good blocks if you're obtaining local execution payloads. A lot of people use it for additional purposes. They'll use it as an RPC node or similar. And ultimately, if our current campaign out there is highly successful, Geth may well become a minority client and something else may become a majority client. In which case we'll be in exactly the same situation, but just, Geth being replaced by Nethermind or Bess or whatever it might be. So it's important to retain that flexibility of being able to move from one to another, being able to say, okay, now, new client is super majority. So actually we can't ask that for attestations. So today you can take a very simple approach and you can just turn around and you can say, okay, great. I'm running 2 different execution nodes. I'm just going to ask Nethermind for my attestation data, all happy, forget Geth, not a problem. That works fine and that works well. However, if you then consider more complex scenarios, then actually what you may want to have is agreement between nodes. So rather than just shutting a node out, maybe what we want is we want to make sure that multiple different execution clients all agree on the correct attestation data to provide the correct chain to attest to. So there's a new attestation strategy going in called majority. A majority does very much what it says on the tin. It will obtain attestation data from all of the connected execution clients. And what it'll take is the one that has the majority of votes. You know, if we've got, say, 3 different nodes out there and 2 of the attestations match and one of them doesn't, we'll take the 2 that match. What we can also do is we can supply a threshold. So if we take, a larger example, let's say there are 4 different attestation, 4 different consensus nodes out there, and we get a combination where maybe it's 2 and 1 and 1. We can get to the point where there's broad disagreement on which particular attestations we should pick. Now, ultimately, and this is again, as with many things in Vouch, it's a strategy and it's there as an option. And the reason it's there as an option is because it really comes down to how you, as a node operator, would like to react in different situations on the network. So in this case, we're looking at a situation where potentially only 2 of the nodes agree, or none of the nodes agree. And the question is, what do you want to do then? Well, you could just pick whichever attestation data you wanted, or you could say that at this point in time, we believe the network is in an unstable state. So we're not willing to attest to anything. Now, yes, that will create a situation where potentially you're going to take a minor loss in your validator because you're not attesting to anything. But equally, it may be important to you that in a situation where the network is unstable, where you cannot get any agreement from your nodes, that you don't attest to anything, that you play safe, that you make sure that you have a certain threshold you have to meet in terms of agreeing nodes before you proceed. So the majority attestation data strategy also has within it the concept of a simple threshold. So you might be the majority. You might have managed to get 2 of your 4 nodes to agree, but your threshold might be 3 of the 4 nodes. You might want to actually have a higher level of agreement, in which case, even though you've got 2 of the 4 nodes agreeing and the other 2 disagree, it's still not enough to meet the threshold. It's still not enough to create an attestation. As said, there are lots and lots of different ways of looking at these things. There is no simple single answer, because a strategy that works well in one particular situation may not play as well in a different one. You can have actual chain splits. We can have network outages. We can just have nodes that for whatever reason lose a lot of their pairs, and so they have a slightly different view of the network. There are lots of different things out there that can happen, but it's very, very important to make sure that what we try and do is ensure that we have the best option available according to your own preferences. So there are lots of other minor little bits and pieces going into the next release of Vouch, but they are probably the major ones out there. I'm happy to take any questions on Vouch if people are interested. The current version, the new version coming out, or just more generally.
I'd like to ask some questions around the attestation strategy. So let's take the simple example that you mentioned in the beginning, which based on your response on the forums is also the strategy that you're currently using for the validators that Attestant BVI is running as a part of the Lido protocol, whereby Geth is not used to validate execution layer blocks. So what happens if your own nodes, your own validators, propose blocks that are proposed by Geth, or as the case is very likely proposed via MEV boost, so almost certainly proposed by Geth because most builders use Geth. is there a possibility that your own nodes will end up not attesting for these blocks if the execution layer that you have that's providing that the validity of the attestations is in disagreement?
Absolutely. So proposing and attesting, if you want to think of it, are two completely different phases. So regardless of who proposes a block, where it comes from, immediate relays are a good example. You know, we can't do any validation of this before we actually sign the thing. So we are very much signing blind. That block is then sent out on the network. Now, regardless of who proposed it, if we assume it was generated by a Geth or Geth similar execution node and is not imported by the other execution node, so say, you know, Besu doesn't like it, Nethermind doesn't like it, then we'll end up in a situation where Geth thinks, let's say, you know, block 7, which is our block that's just been proposed, is the current head, but Nethermind and Besu will think block 6 is the current head because they looked at block 7, they failed validation on it, and so they threw it out. So what we want to do then is we go back and we say, okay, when we're going to get attestation data, we'll talk to the consensus nodes connected to Nethermind Besu, basically not Geth. And that will give us block 6 as the current head of the chain, and we will attest to that. Now, that's all fine. And the common question is, well, what happens the other way around? What happens if it's Nethermind that's got the bug and it creates a bad block when it imports a bad block? Well, the answer is we will attest to the bad block. But because Nethermind is not a supermajority, we will not cause the chain to split. We will not cause a finalization issue. What will happen is purely that they'll look at our head vote and go, nah, wrong. And as a result of that, our attestation will lose a small amount of money. But obviously, this is now in a situation where we actually have bad blocks being produced and we're still gaining the majority of the funds. Our source vote will be correct. Our target vote will be correct. And so we're actually okay, and we'll keep going. Now, over time, that will decay. We will lose target vote as we lose finalization on the chain, but we will only lose that locally. And again, there will be no long-lasting impact to the chain. And again, once that is fixed, then we will come back up and we will carry on attesting normally. So certainly, when we consider the impact of a bad block, we should consider the impact of a bad block being produced by a non-supermajority client, of being accepted by a non-supermajority client. And in fact, that's exactly the situation that we saw, where there was a split between Nethermind, where it decided certain blocks were invalid or not, and the rest of the network where it decided certain blocks were invalid or not. But Nethermind does not have enough percentage of validators behind it to impact the chain. It would need to be at least a third for the chain to stop finalizing, at least 2/3 for invalid chain to finalize, and that hasn't happened. Now, ideally, we'll get to a stage where we have 4 execution nodes with 25% each, 5 execution nodes with 20% each of the network, and then everything will be calm and easy, and the only potential impact is to local validators themselves. Until we get there, we need to be a little bit more careful about the nodes to which we listen to understand the head of the chain. And we should always go with the minority nodes, because even if they're wrong, the impact on the chain overall and us as validators and node operators is much reduced.
That's a really, really great tutorial on attestation and validity. There's a small kind of implied assumption here, which for now probably isn't very key, but eventually may be interesting to think about. And that's that each client is kind of isolated and independent in its interpretation of the spec. But it's theoretically possible that 2 clients together who would comprise a supermajority, or hopefully not, but maybe just a majority, may have the same, let's say, incorrect interpretation of the spec. Or you might have 4 clients all at 25%, and 2 have the same interpretation of the spec, and the other 2 have the same interpretation of the spec. In cases like that, how do you go about determining what's actually the canonical chain?
So if we take a simple example, then that last example you gave, let's say we have 4 clients and each has 25% of the network. The great news there is that if two go one way and two go another, all we end up with is a non-finalizing chain. So we're in luck. What happens is the client teams will have to sit down, work out which ones are correct and which ones aren't, patch the clients that are not, and then bring them back online. When they bring them back online, we will immediately get back to a situation where we can then finalize at the next epoch or the 2 epochs down the line. So it's one of those situations where, and everyone worries about the supermajority, and they absolutely should, but ideally we want to get everything down so that if 2 clients have a different view, we'll still be in a situation where the worst we have is a non-finalizing chain. Now, look, the reality is, unless we have at least 6 different clients and they are all having an equal share, we're always going to be in a situation where if 2 clients disagree, then we hit some kind of issue. But realistically, if we can keep the percentages fair and even, then that issue will be a lack of finality rather than finalizing an invalid chain. So in terms of, internally, how would Vouch choose? Well, it depends what it's talking to. As we talked about with the majority system, potentially you could set it up so it won't. It could just refuse to attest to anything. Now that's playing it safe. It's losing a little bit of money, but it's only a little bit of money compared to what you could lose if you finalized on the wrong chain. And again, one of the things that is very important to understand, and one of the reasons Vouch has all this in configuration rather than hard coding anything about Geth, is because, as we have seen on the consensus side, the mix of clients can change. New clients come up. Existing clients that are dominant might come down a bit, either because people are worried about them being dominant and having a supermajority, or because other clients fill a hole. We have, when we look back at a few years back now, when Prism had a supermajority on the consensus side, we started seeing clients like Nimbus come up, much lower resource utilization. So there wasn't just a case of move off the supermajority client, it is bad for you, because as we've seen, it's a relatively tough message to get across. But for people who are coming on board and going, well, actually, Nimbus looks like a great option. It's got much lower resource usage. I can put it on a smaller box. I can save myself money. There was a natural move to it. So as long as we can keep those clients flowing, as long as we can see that happen, then that's going to help us. And we may see over time that once dominant clients become less dominant and become absolutely subservient to a new dominant client. So we might find that actually the percentages change. And if that kind of thing happens, then we're in a situation where we've got the same problem, but it's not Geth anymore, it's Nethermind or whatever else, right? So it changes around. So we need to make sure that we have the flexibility to chop and change without kind of hard coding the idea that we don't trust Geth particular or whatever else. We've seen on Twitter over the last few days some large stakers turn around and saying we're reviewing our usage of Geth. If 3, 4, 5 of those people turn around tomorrow and said, oh, we're all moving to Nethermind, we're going to have exactly the same problem, but with Nethermind. And it's going to be one of those situations where we have to recognize that our aim is certainly to reduce the supermajority, because that's the critical issue. But then beyond that, it is to bring ourselves down to the state where either we have a very fair share across 4, 5 different execution clients, or we have a system that allows us to look at multiple nodes, multiple different execution clients, and make sure they all agree before we progress.
Absolutely. And hope that there's no weird confluence of spec misinterpretation amongst a multitude of clients such that they might comprise a supermajority. But obviously, the more you spread stake share amongst clients, the less likely something like that is. If you have something lopsided, yes, like 50 plus 20, then it can still happen, right?
Absolutely. Absolutely. So we need to get it down far enough that we hope that the different teams between them have independently built the software out, and all of these bugs get caught. And it can happen, kind of. If we look at the original beacon chain and the spec there, there was an idea that a proposer gets 12.5% of the attestation rewards. Due to a slip up in the code or in the spec, it was a quarter of that roughly. And no one caught it until after the system had released, and all of the beacon nodes were happily following along with that. So absolutely it can happen. But again, we learn from that type of situation, and we try and make sure that people are much more clean room. One of the other problems of having a supermajority is you tend to use it as a reference. So again, if you go on to Geth and you run a JSON RPC call against it and it gives you a certain information back, you're going to assume everyone else does the same thing. All the other nodes do the same thing. You're not going to wonder if it's exactly correct or not. You're just going to go ahead and use it. Unfortunately, you will also see the situation where potentially the other node developers will do the same thing. They'll look to the majority client to see what it does, and then they'll copy it. Now, again, we're addressing that. There's the execution APIs as a separate repository coming out. People are trying to define what things should be absent of any client, and then get each of the clients to implement it separately. So the more and more that we build these systems in, the more and more that we are spec driven with multiple implementations, as multiple implementations are independent, the lower that likelihood is. But yes, it's always a possibility, absolutely, and something that we need to protect against. And as we say, once we get our supermajority client down to less than 2/3 of the share, we should be getting it to half of the share, and then we should be trying to get it to an even share along with every other execution node we have out there, because that's the only way that we can be as safe as possible.
Fully agreed. All right, I see one question from Torsten. Vouch uses Dirk for key storage. For someone running another validator client right now, what are good practices or perhaps best practices to move to Vouch? I assume it doesn't integrate with the Web3 signer.
Okay, so no, it doesn't integrate with the Web3 signer. Is a nice simple start. So we've talked about Vouch. Dirk is Attestant's key system. So it allows us to store keys, and it allows us to manage signing operations. So it provides the anti-slashing features. Traditionally, Dirk is run in a distributed system. So for example, you might have a threshold of you need 3 signatures out of 5 separate servers running Dirk. Only 3 of them need to provide the signature back to Vouch for that signature to be valid. You don't have to run it in that way. So if today you were running, let's say, Web3 signer, then you could install Dirk next to it. You could shut down Web3 signer. You can import the keys into Dirk, and then you can use Dirk instead with Vouch. The format between something like Web3 signer and something like Dirk are ever so slightly different. The various reasons for that, not least of which is that we provide, again, we mentioned earlier optimizations. One of the optimizations we provide is batching. So if you've ever run, for example, the Teku validator client, because I was running that recently, and you put 1,000 keys behind it, you will sit there and watch as it starts up, and it will say, I've done 10 keys, 20 keys, 30 keys, 40 keys, and it will keep going for a while. So it takes a while until it ever gets up and running, because you have to decrypt each key individually. If you look at something like Dirk, then it has functionality at the back end where it will batch all of the encryptions together. It will put them, so it'll basically decrypt all the keys individually, put them into a single large encrypted file, and then it will decrypt that one file, which means that startup time is largely independent of the number of keys you're running. So that type of thing can make things a lot faster. But yeah, in terms of moving to Vouch, Vouch only uses Dirk as the back end. And there are all sorts of reasons around that, including historical ones. But one of the things that we've always tried to do is ensure that security is first. And some of the features in and around Web3 Signer, certainly when it provides multiple systems with the same keys on, and then having a sort of centralized database to protect against multiple signings and similar, is not something we're comfortable with. So the reality is in that situation, we would say, yep, you can import your keys from Web3 Signer into Dirk. You can then run Dirk with Vouch behind it, and that will allow you to move over relatively cleanly and relatively easily. Certainly one of the things that would be very interesting, if anyone listening on this call, for those of you who are interested in doing something like that, always happy to sit down and chat. I'm in the Discords, I'm on the Telegram groups. I'm sure most people can find me if they want. Certainly looking at how we can do some of those migrations and making those migrations easier for people is something that we are interested in doing. We recognize that lots of people are out there running staking systems already, not using Vouch. That's fine. But if they want to move over to them, then migration guides are not something that we have today. It's not something that we've been heavily involved with, but certainly, if people are interested in doing those migrations, that will allow us to look at those processes, provide more details, and eventually, ideally, guides to help people migrate over.
Just waiting to see if there's any follow-up questions from Torsten, but it seems like no. I have one more question about something that you brought up during your presentation, with regards to the threshold configuration around attestation consensus, let's say basically for validity of well, not validity of the attestation itself, but whether the attestations are provided by the attached execution layer nodes. Is the threshold relative or absolute? And what do I mean by this? Let's say you have 3 nodes connected and you have a consensus threshold of 2 out of 3. Does it require a minimum of 2 actual responses? Or, for example, actually, this case is not good because if you remove 1, you can never reach that threshold. But what I'm trying to say is if you can get the percentage, but you don't have the actual absolute number of responses, like what does Vouch do in that case? Does it require a minimum amount of actual responses? And therefore, if it doesn't get them, like not attest or not vote at all?
So again, if you set a threshold, that threshold is an absolute number. So and that's critical, right? Because we don't want to be in a situation where we can, because some client has gone down, suddenly, a Geth related thing has leapt over the threshold. If Geth is the only response, but we want to have 2 responses that match, then we don't want to be in a situation where it's like, well, ideally it would all match, but Geth's the only one responding, and so we'll move ahead with Geth anyway. So the reason we don't want that, of course, is because if, let's say, there's a situation where Nethermind gets the other node, it gets a bad block, and because of that, it goes into a bit of a tailspin. And again, historically, we've seen this on the consensus side, where when we get into non-finality and similar, nodes get overloaded. If suddenly the other nodes fall over or are unable to respond because they're busy elsewhere, we still want to make sure we get that absolute guarantee. So thresholds are always absolute numbers. And again, it will fail safely as far as we're concerned. If it can't get the threshold it needs, it will not attest. And that's, a very important situation, we believe, that matters. Now, equally, if you don't want that to be the case, then you can just remove the threshold and it'll go with whichever attestation data has been a majority response. And if that is Geth, then so be it. So you can certainly have all these different variables and varieties and ways of doing things. And again, it really comes down to the specifics of how you want your system to react in any given situation. As we said, it might not be as simple as we've got a chain split, Geth's gone bad or whatever else. It might be, the vast majority of situations are, I have 3 execution nodes and 2 of them are in different data centers and the network's gone a bit flaky. Most of the situations you meet will be far more operational than some major protocol failure. So you need to understand kind of how you want to handle it. And again, it can be different situations. You might have 3 execution nodes all sitting on the same machine as Vouch, in which case you're not worried about network. They might be scattered around the planet, in which case getting a threshold matters. Having a certain timeout matters. So depending on your configuration and architecture, lots and lots of different ways in which you could configure it. And it really then comes down to, again, your own operational decisions as to how you want to act in certain situations.
Awesome. Very, very thorough and lucid as always. Thank you very much, Jim. I don't see any more questions, so that about wraps it up. Thanks to all of our attendees for their awesome presentations. Looking forward to the Vouch beta not being a beta anymore and the full release, so that some of these things can start to be incorporated on mainnet. And next month, we're going to have our next iteration of the node operator community call, hopefully with some really, really great news to share on SimpleDBT. Because if all goes well and the DAO approves the deployment, the SimpleDBT module will be live on mainnet. All right. Thank you, everyone, and have a good evening.